Assalamu alaikum. Today I will explain the topic infrared spectroscopy. Here is the table of contents and let's discuss each one by one. What is spectroscopy? Spectroscopy is the study of interaction between the matter and electromagnetic radiation. What is IR spectroscopy? IR spectroscopy stands for the infrared spectroscopy and it is concerned with the study of absorption of the infrared radiation, which cause vibrational transition of bonds in the molecule, so it is also called vibrational spectroscopy. IR spectroscopy mainly used to identify the functional group but also give information like number of bonds, specific stereoisomer, atomic arrangement in the molecules. There are basically three regions of the IR infrared spectroscopy. First of all is near IR, mid IR, and then at the last far IR. All of them have different wavelength and different wave numbers. Infrared with ultraviolet radiation and gives extra band on IR spectra due to delocalization of electrons, while FIR is also closer to the radio wave region and sometimes bandly interact and formed extra unwanted band spectra on the spectrum. The wavelength we use for the IR spectrometry is from 2.5 to 5 macrometer. Macrometer is the unit of IR. Here is the picture of IR spectroscopy. The wavelength stands for 0.75 to 6. Principle. What is the principle? When the IR radiation interact with the sample molecule will absorb the specific applied quantities IR light which is matched with the internal vibrational frequency of the molecule, and the other residual frequencies are transmitted via the sample. Due to the absorption of infrared radiation, the net change of the dipole moment in molecule is occurred and causes vibration of the bonds in the molecule like stretching and bending vibration. Next, here is the picture how we can get the graph IR radiations and then sample, then transmitted light, and then we saw the graph at the computer or the screen. Position change of atoms in the molecule due to net change of dipole moment when we sample place on the IR radiations, change in amplitude of the molecular vibration, and then it causes the stretching and bending. What is the working or method? The source energy strikes the beam splitter and produces two beams of roughly the same intensity. When the source strikes the beam splitter, there are the two types of beams which have the same intensity. One strikes with the fixed mirror and the other returns to the beam splitter. The other beam goes to the moving mirror. When these two beams meet up again at the beam splitter, they recombine. The recombined beams passes through the sample. Here is a picture again: Fourier transform spectrometer, stationary mirror, moving mirror, and the beam splitters. And the sample are detected in the computer, and so we get the graph like this. So here's the sample. One beam is at the stationary phase and other is at the moving mirror. What are the conditions to absorb the IR radiation? When applied infrared frequency is equal to natural frequency of vibration, then the absorption takes place and peak is observed. Only molecule gives IR absorption. Molecules must have a dipole moment. The mode of vibration must have the double bonded shape. Wave number equation. Here is the equation: V is equal to R1 over 2 pi c K over micrometer under root large K higher frequency, and it stands for the large atom mass is lower frequency, and pi is the constant here. Next, increasing K value and increasing micrometer value, while the V stand for the wave number. What are the factors which affect the IR peaks? There are two types of factors affecting shape and intensity. Next, in the shape, broad and sharp. ड्यू टू द हाइड्रोजन बॉन्डिंग और द प्रेजेंस ऑफ वाटर मॉलिक्यूल। इंटेंसिटी स्ट्रॉन्ग भी हो सकती है, मीडियम और वीक। Strong. A strong band covers most of the y-axis. Medium band falls to about half of the y-axis, and a weak band falls to about 1/3 or less of the y-axis. Factor affecting the peak intensity: electronegativity difference, polarity, dipole moment, and more intense peak. These are basically 4 factors which are more affecting the peak intensity. What are the applications? To identify the organic compounds, it is used for the structure determinations, it is used for the identification of functional groups, it is also used for the study of the progress of reaction, distinction between two types of hydrogen bonding, study of ketonal tautomerism, study of cis trans isomerization, conformation analysis, determination of impurities. Here are some limitations of higher spectroscopy. It cannot determine the molecular weight of the compound. It does not give information about the relative position of different functional groups, which are very necessary. Sample cells are made of halogen salt, which are susceptible to moisture. The gas samples cannot be analyzed as the lack of